Okay, we're told that men's height are normally distributed with a mean of 70.1 and a standard deviation of 2.8. Women's heights are also normally distributed with a mean of 63.7 with a standard deviation of 2.5. Okay, makes sense. Women are shorter than men, but less variability because you have less room to move. Standard doorway height is 80 inches. Okay. What percentage of men are too tall to fit through a standard doorway, and what percentage of women? Okay. Well, let's see what we've got here. It's always good to start with the picture. That should be the first thing you always do, is draw the picture. So what do we got going on here? We have our normal little curve here, and here's our mean. And so as a z-score, this mean is 0. But for men, it's 70.1 here, and women 63.7. We want to be out here at 80, and we want to know what this is. How much of men and women are over this 80? So the first thing we have to do is we're going to have to find what the z-score is so we can look at both of these. Now remember, when we look up this in Excel, Excel always goes to the left. It goes this way. So we're going to have to subtract what we get in Excel from 1, because everything under here has to be 1. All percentages have to equal 100. So we can subtract everything we get from 1, and that gives us what's left. So we're everything 80 and above. So what percentage of men are below 80 inches? That's what Excel is going to tell us. We're going to subtract it from 1, and it's going to tell us how many are above 80%, because it's 100%. You're either below or you're above. So I'm going to get up in Excel. Now, remember, in Excel, we have the option of converting to a z-score first, or we could just use the normal distribution to go straight to, and that's what I'm going to do here. So I'm going to do, we've got here men, and we've got women. So I'm going to do men first, and I'm going to go to formulas, more functions, statistical, and I'm going to go down here to the ends, and I want normal distribution. Now, if I went to normal S distribution, I'd have to have a z-score. I'd have to convert it. Now, I can do that, but it'll do it for me, so why? Normal distribution. So my x is 80. That's what I'm looking for. My mean for men was 70.1, and my standard deviation was 2.8. And I want, always this is true, I want the cumulative function. You don't want the exact one, means nothing here. So that means that 99.9798% of men are 80 inches or below, which that makes sense. 80 inches is incredibly tall. So we're going to do 1 minus B1 because we want to know what that is. So you can see here that the number of men is 0.0002. So this asked us to round, so turn this into a decimal, move it over. We're at 0.02%, but this said round to 2 decimals, so this is 0%. Now, I'm going to work out women here, but obviously if there's 0% of men who are above 80%, there's 0% of women too. Man, it doesn't, oh, come on, I'm right. Did it want the 0.02? I don't think so. I said rounded to maybe 2 decimal places? Oh, I guess, okay, 0.02%. I was getting a little bit more specific than I was getting. I was thinking 2 decimal places. Okay, whatever. Anyways, we had the right answer, right? Because, of course, what I'm really doing here, guys, is I'm timesing this by 100. Yeah, come here. Oh. C1 times 100. So this then is my percentage. Normally we're seeing like 2% or something, but in this case it's 0.02%. So now we're going to go here, statistical, and I'm going to go do this again. Normal distribution, 80. What was women? It was 63.7. That's not what I just put in, 63.7, and I'm going to go back and check that. 63.7, yep, and 2.5, and true. Okay, and so this is telling me that there are no women. Now, I don't know what the tallest woman in the world is. There might be one, but obviously it's not enough to matter. So then obviously if we do B2, 1 minus B2, we're getting, and you can see this obviously isn't quite 1 because this is giving us, that's 11 zeros, okay? Well, 10, because you're going to have to go over the 1, but still 10 zeros. Even rounding, I'm going to go times 100. Oh, it's kind of mad at me, huh? Because it really does want me to put in a number. I don't know why. Yeah, you can see we're so many zeros. This is 0%. So I'm going to go here to 0%. Okay, now, what was the second question? If a statistician designs a house so that the doorways have a height sufficient for all men except the tallest 5%, what would the doorway be used? Okay, well, let's go here. You can see here, this is the conversion formulas if you wanted them here. So now we've got this again. We've still got our mean coming here. Here's our mean. But what we want to know is we don't know what this is. Before we knew it was 80, but we want this to be 0.05. We're like, we don't care if the tallest 5% bend. And of course, we're just talking about men because if the tallest 5% of men bend, less than that of women are going to bend. So we're like, okay. Now, looking at our chart, though, our chart always gives us the left, right? So what do I want to look up? I want to look up 0.95 or 1 minus 0.05. So what I'm going to do here is I want to look up 95. I want to know where this 0.05% is, okay? I have to look up the 0.95. So now when I go here, I'm going to go down here, and I'm going to look up the normal. You look up the normal S distribution. I want one of these inverses. I'm going to do both actually here for you. Normal S distribution, I would put in 0.95 here. And this tells me what the z-score is. Now, to find this, what I would do then is I would go back to my formula here. There we go. And I would put x in for here, because I don't know what this is. But I know now that this is 1.645, and I would simply solve for x, and this would give me what the value is. So if I do 1.645 times 0.28 plus 70.1, it tells me 74.7. Now, my other choice here in Excel is I can go down here. Now, instead of using the normal S distribution that I used, I can use just this normal inverse, okay? So the distribution, this is when I'm going forward. When I'm going backwards, I'm using this, the inverse. So the probability, again, 0.95, but now I'm going to put in my mean, 70.1 and 2.8. In other words, it's going to do the formula for me. So there's my 74.7. Same answer as before. So it said round to the nearest 10, 74.7. So that means if I make doorway heights that, only 5% of men are going to have to bend. So you can see when using Excel, one of the major keys you need to remember is make sure you're drawing the picture. It's going to help you with setup. If you don't draw the picture, you really don't have any frame of reference. And Excel is especially tricky because unlike the table, you don't have the picture to work with. So you need to create that picture to make it easier to work with.